Hi everyone, this is Bob Yantoska from the GEOS-Chem support team. Today we're going to be logging onto the Amazon cloud platform, and we're going to be using Spack to build a copy of the GNU-Fortran 9.2.0 version of the compiler. So if you've never gone onto the Amazon cloud before, we have a web tutorial which is shown here. You'll come to this page if you type cloud.geoschem.org. So this goes through all the basics of how to get started onto the cloud. For example, here is a quick start guide for new users. So it goes through the steps involved in making up an Amazon Web Service account for yourself and so forth. So I'm going to skip over this for now because this is pretty much self-explanatory. But eventually, if you create an account to log into the cloud and you log in, you'll come to the EC2 dashboard, which is the Elastic Compute service. And it'll look like this, although on your web page, I have it kind of scrunched down here, so it may look different if you have a wider browser. So what we're going to do is to come down to this box and click on Launch Instance. And this will bring us to a page called Choose an Amazon Machine Image. So an Amazon Machine Image is basically the base software for your computing session. So it contains the operating system and some predefined software libraries. So what we want to do is you typically need to search for an EMI. Here we're going to type in GEOS-Chem, capital GEOS, capital C, lowercase chem. And as you can see here, we already have several predefined AMIs that you can pick from. So I'm just going to scroll down the list, and I'm going to pick the GEOS-Chem 12.6.0 tutorial, which is the most recent one. Note, as of this, the day of this tutorial, 12.7 is still in benchmarking. It hasn't been officially released yet, but we hope that that will be released soon. So this is basically a self-contained tutorial for GEOS-Chem 12.6. So we can select it, and this will bring us to the next page, which is Choose an Instance Type. So an instance is the hardware that you're going to run in your computing, cloud computing instance. So what I'm going to do is I'm going to search for memory optimized, and I'm going to pick R5 4X large, which is a good one for GEOS-Chem, for at least small types of GEOS-Chem operations. The next thing we're going to do is configure the instance details, and the only thing we need to do is we want to be able to look for the IAM role. Here it is. And we want full S3 access from EC2. This will allow us to grab data from our S3 bucket. I don't think we'll need it for this tutorial, but I always do this when I start an instance. And then review and launch. And so what it says here is a summary of the instance. Where it says vCPUs, I believe this is equivalent of 1/2 of a core. So a vCPU of 16 means you have an equivalent of 8 computing cores. And so we're going to launch. Everything looks good. It asks you to select an existing key pair. I have a predefined key pair. The key is used for SSH, so log in with SSH and file transfer and so forth, secure shell. So then what we're going to do is launch instances, and it just takes a minute. And your instances are now launching. So if we go to this page, View Instances, now we see this one is pending, so we have to wait until it says running. And then we can start working with it. So it usually takes a few seconds. In the meantime, I want to talk about how to use, a little bit about how to use Spack. I'll go up to this page. Now, this is in our guide to NetCDF in GEOS-Chem. There's a page called Use Spack to install NetCDF on your system. Well, we're not going to be installing NetCDF in this video. That will be the topic of a future video. But basically, the the steps you need to take are pretty much the same whether we install netcdf or a compiler. And so I'm going to use this as a basis. So let's go back to our instances page. And now we see it's running, so we can connect to it. So we come to this instance, and we can right-click on it, and it'll show in the context menu, it says connect. So we'll click on that, and it shows this is a little, we want to connect by a standalone SSH client. That just means a terminal window. And it gives us the command to log into it. Now note, it always says root, although I happen to know that this particular instance, the account name is Ubuntu and not root. So I'm going to just copy the address of the instance, which is just this last part of this command. We'll just copy it, and I'll type SSH Ubuntu at, well actually I don't need the at. Now notice, like it says SSH in the name of your key pair, I have this aliased. My SSH command in my shell is alias to that, so I don't have to type it. But you may need to type it. You can just cut and paste this whole command and just change the Ubuntu. And if we hit return, we see that it gives us this message, which is all that this is saying is that I've never connected to this particular machine before. Do you want to continue? And the answer is yes. And it's going to log us in to the node. Now we are running within a cloud computing session. So if we type ls, you'll see that because this is a predefined AMI for the GEOS-Chem 12.6.0 tutorial, there's some folders here. There's one called ext data. This will be the data directory, and I believe ext data has some sample data for GEOS-Chem and so forth. There's a tutorial folder that I believe this has the code directory and the unit tester and a sample run directory. So we're not going to be concerned with these for now. But what we want to do is to go back to our Spack installation guide here. For those of you that may have never heard of Spack, Spack is a new package management tool that basically allows you to build libraries very simply. And the killer app, or the most amazing thing about Spack, is that it will not only download the library that you need, but it will also download all of the dependent libraries. So for example, if you're building netcdf, it will figure out, well, netcdf needs this and it needs that and it needs that, and it'll grab all those libraries and build them for you, and then it will build netcdf, the last thing. So it's a very good way of standardizing software stacks for high performance computing applications. And it's very simple to use. The complete documentation is found at spack.readthedocs.io, and I recommend everybody take a look at that. But to get started with that, you only need to know a few basic commands, and I'll try to pull this up to the page here. So Spack is distributed via Git, so all you need to do to install it is do a git clone command. So git clone from their GitHub, which is listed here. So I'm going to grab this, and we'll just copy and paste into the SSH window into my cloud instance. And it just grabs it via the git transfer. And if we do a ls command, you'll see that we have a Spack folder here. Okay. Now, then the next thing that we need to do is to set up the environment for Spack. So there is a environment variable that we need to define, which is called Spack root, which is just basically the path to Spack. So our home directory is home Ubuntu. So all we have to do is say export, and I'm running in bash shell. If you're running in T shell or C shell, it may be a different. If you're on your computer cluster and you're following along and use a different shell, the commands would be a little bit different. But here I'm using bash shell because this is pretty much the most common shell in high performance compiling. So I'm going to type export spack _root in capitals equals home Ubuntu Spack. Okay? And then we need to copy this command, which this basically runs a setup shell which initializes some things for Spack, and I think it puts the path to Spack in our path variable so that it knows where, the Unix shell knows where to find it. So I can just copy and paste this. So this dot is basically the same thing as if we said source. So we're like you say source bash rc or source bash aliases or anything like that. And so we let it do its thing. And now at this point we have installed Spack and we've done the initial setup for Spack. Now we need to know that we need to make sure that Spack can find our compiler. Okay, so you just want to say that I said we're going to be installing a compiler with Spack. We need to have a compiler to start with, because the dirty secret of compilers is that every compiler has to be built from an older compiler or a different compiler. So for example, in this case, if I say GCC version, there's a version of GCC which is the GNU compiler collection. In this case, this is the C compiler, but there's also a C++ compiler and a Fortran compiler. So with the AMI comes a version of GCC and also even gfortran version 7.4. So we're gonna have to use this version of GCC and gfortran to build the version of GCC 9.2 that we want to build. So just to let you know about that. So if you type Spack compilers, it says here are the available compilers, and so Spack knows where to find the compiler that's already installed with this instance. And if you type this next command, spack config get compilers, this shows the whole spec of the compiler. So this is GCC GNU compiler collection 7.4, and it has these compilers. So CC is the C compiler as found in the executable is found at this path. CXX is the C++ compiler as found at that path. And both the F77 and FC variables point to the gfortran compiler, which is found at that path. And it says operating system Ubuntu 18, which is the operating system that comes with this cloud environment, or the cloud AMI. So it's very important before you start using Spack to install a package, you want to make sure that Spack knows about the compiler that's already there, so that otherwise you'll have to tell Spack about it. So for example, if we did this command, spack config get compilers, and there was nothing here, what you could do is edit the spack.spack.linux in your home directory, tilde.spack linux compilers YAML file, and that you would basically have to type out all this information and save the file, and then Spack would know where to find your compiler. Okay, so that's so we know that Spack is installed. We know that Spack can find our compiler, and the basic installation command is very simple. We just type spack install and the name of the package that we want. In this instance, we were installing netcdf fortran, so that's what's listed here. But what we can do is type spack install GCC. Now, before we do that, we should take a look and see if there are any, what the most recent version of GCC is available to us. So what we can do is to type spack find. Spack find, I always get these mixed up. Spack find shows what is on your system already. So there's nothing on our system. We haven't installed anything yet. So spack list shows a list of everything. If you just type spack list, you'll get a list of all the packages that can be installed with Spack. So I think if you type spack list GCC, it'll show you 3 packages. which isn't very helpful. But then I think now I remember it's spack info GCC is the right command. And so if we go here, spack info GCC, this tells us this is the GNU Fortran compiler with all these, the GNU compiler collection with all these compilers in all these languages. The preferred version is this. You can get older versions, and there's even a development version. But because the preferred version is version 9.2.0, that's what we're going to take. Okay, so what we can do is we can say spack. There are a couple of ways you can do this. You can say spack install GCC at 9.2.0. The at command lets you specify a version number. So this assumes that spack will use the compiler in the specification. So if we type, again, remember when we typed spack config get compilers, right now we only have one compiler defined here. But what happens if you have more than one compiler and you want to force spack to use a specific one? Well, instead of typing spack install GCC at 9.2.0, which would just install GCC version 9.2.0 with whatever compiler you have here, you can force a specific compiler. You can say %sign GCC 7 at 7.4.0. So this means we want to install the GCC GNU compiler collection version 9.2.0 using the GNU compiler connect collection version 7.4.0, because this is the version of the compiler that we have on disk already. I always like to use the %sign to be explicit so that you know that you're not installing something with the wrong compiler. So if we type this, it's going to start percolating, and we will soon see some text being built or text being output to the screen. Spack first figures out the tree of dependencies, so it figures out which of the packages that, for example, GCC version 9.2.0 needs, and then it needs to download those to disk, and it needs to build them from the source code. Unlike other package managers like APT, as you get on Ubuntu, those package managers like APT just pull pre-built binaries. So that means they've been built by somebody else and that you just grab them into your Unix environment or Ubuntu environment. Spack builds everything from source code, which is great because in many cases it's hard to mix and match pre-built binaries. So when you build something, you should really build everything from scratch using the same compiler. So this is going to take about 40 minutes, a half hour to 40 minutes. So I'm going to pause the recording here. But as you can see, it's just percolating. It's downloading stuff. It's executing configurations. It's building it and installing each package. So we'll come back to this in about a half hour. And until then, I will see you soon. Well, hello. So this has been about 35 minutes or so since I paused the video, and Spack installed GCC version 9.2.0 successfully. Now there are a couple of steps that we still need to do before we finish today. The first of which is we need to again make sure that Spack can find our compiler. So if we remember, if we type Spack config get compilers, right now there's only one spec. So even though Spack has installed the compiler, it doesn't know that it can use the new compiler that we just installed. So what we're going to have to do is to edit this file, Spack Linux compilers YAML, or .spack Linux compilers YAML, to put the new compiler spec in there. You might be asking, where did Spack install the GCC file? So the quick way to find that out is to use the Spack location command. So we can type Spack location -I GCC 9.2.0, and that gives us this big long file path. So if we list this, if we type ls with this big long file path, you can see there's a directory tree under here. So the compilers themselves, the executable files, are all in bin. So you have GCC is the C compiler, gfortran is the Fortran compiler, G++ is the C++ compiler. So this is the path that we need to give Spack to tell it where to find the compiler. So what I'm going to do is I'm going to bring up an Emacs window. Emacs is our favorite text editor, and we're going to go look at Spack Linux compilers YAML. Okay, so the easiest way to update this is I'm going to just copy and paste this. Okay, and so in the new compiler, that's going to be Spack GCC 9.2.0, and then we need to get rid of all of these paths and edit the new path. So I'm just going to cut and paste everything. Is home Ubuntu Spack blah 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 bin is the path. So GCC, that's the C compiler. This is the variable that tells you where the C++ compiler is, and that's G++. F77 is the Fortran compiler. And actually F77 and FC are equivalent because gfortran handles both F77 and F90. And everything else is the same. Okay, so then we save this file. And now if we type, I'll just do up arrow, Spack config get compilers again. Now Spack has also picked up this extra spec here, so it knows about our new compiler. Okay. There's one more thing that we should do as well, is we need to put the path to the new compilers in our path, our Unix path variable. So for example, if I typed gfortran _version, which is going to tell us the version number of gfortran, you can see that it's still pointing to the old, oops, let me scroll back down, it's still pointing to the old version, which is 7.4.0. So what we can do is go to our bash RC file in the instance, and we can look for where it says path. Okay, so in this command here where it says export path, this is adding the path to the miniconda, which was the Python path. It puts that in the front of the path variable, so we'll look for there first. So what we're going to do is put the path to the bin folder of this big long path, so that we'll know to look there first before it looks at user local bin or user bin, which is, or wherever the other the older gfortran compiler is installed. So I'm going to edit this. I'm just going to paste that, copy and paste, and I'm going to put a colon, and I believe that's right. And actually home Ubuntu can just be replaced by $home. It's the same variable. So I'm going to save that file, the bash RC. This is the main startup file for our Unix environment. And then I'm going to do source bash RC. And then now when we type gfortran version, now notice that it's pointing to, oops, sorry, with the mouse arrow, it's pointing to the Spack built GNU Fortran compiler. So not only have we installed the Spack compiler, the GNU Fortran compiler with Spack, our Unix environment now knows where to find it, and we've also told Spack where to find it. So at this point, when we build new libraries, we're going to be telling Spack to use the newest compiler to build extra libraries like netcdf. I'm not going to cover that in this video. I will cover it in a follow-up video, so stay tuned for that. Before I leave, I would just like to give a plug to our YouTube channel. We have a GEOS-Chem YouTube channel. The easiest way to reach it is to type YouTube or http://youtube.geos-chem.org, which will bring you to this page, and you'll see that we have several other tutorials. There are a few tutorials that we've done recently on GitHub. Please subscribe to this channel and click on the bell to be notified of new videos, because that's a good way of keeping up when we put new tutorials up, so that you'll know when a new tutorial video is published. So I'm Bob Yantoska for the GEOS-Chem support team, and I'll see you in the next video.